Alright guys, welcome to this page of the notes, and here's what we're doing. I got a few example problems for us for the side angle side triangle congruence theorem. Again, all you have to do is show that two pairs of corresponding sides and an included angle are congruent, and you have proven that those two triangles are congruent. Let's see what we've got here. I've given you guys two triangles. It looks like, right, if I took this guy, just flipped him over and set him on top of this guy, right, JL and PM would be congruent. And that's exactly what the diagram shows, right? 46 inches, 46 inches. That means that JK and NM would be congruent. That's exactly what the diagram shows. 74 inches, 74 inches. That also shows, right, take this guy, flip it over. That means that angle M would lie on top of angle J, and look at the diagram, 37 degrees. 37 degrees. Well guys, look at what you've got here. I have an side, angle, side. And I've just proven it's congruent to the corresponding side, angle, side. So here's what I know. Side JL is congruent to side PM, or segment PM, and I know that angle J is congruent to angle M, and I know that side JK is congruent to side NM. Therefore, by the side angle side congruence theorem, I know that these two triangles must be congruent. I don't even have to worry about proving the rest of it. If I can show that these three are congruent, right, based on the pic, right? You guys remember this picture right back here? We said, right, if you can show that a side, an included angle, and the other side are congruent, there's only one unique triangle that has those properties. So, since I have proven side, angle, side, I know these two triangles must be congruent. I don't even have to worry about proving the rest of it. Side, angle, side, congruence theorem. Says that triangle JKL is congruent to triangle MNP, right? Side, angle, side. Let's do another one. Well, let's see what we've got here. I think I see it. I think I see it. If you take this triangle, flip it over and set it down right here, here's what I see. I see that side AB and side DE are corresponding sides. And, look, they are congruent. 20 centimeters, 20 centimeters. So, side AB is congruent to side DE. Awesome. If I take this triangle, flip it over and set it down, side AC and side DF, corresponding sides, and sure enough, they're congruent. So side AC is congruent to side DF. Fantastic. One more time. Take this guy, flip it over. That means that angle A and angle D are corresponding angles. If I can show that they're congruent, cuckoo, ka-choo, we've got it. Side, angle, side. Ooh, no go. Angle A does not equal angle D. Angle A is 43, angle D is 45, and again, all you have to do is show that one pair of corresponding angles or one pair of corresponding sides are not congruent, and the triangles cannot be congruent. So, these triangles are not congruent. Again, you didn't even have to do this other stuff, right? If you had just immediately looked at it and gone, oh, I know that A and D are corresponding angles and they're different, as soon as you see this, boom, they're not congruent triangles, you're done, move on to the next problem, right? You only have to show that one pair of sides or one pair of corresponding angles are not congruent, and you're done. You've proven the triangles can't be congruent. All right, I got another one for us here. Let's see what we got. I want you to determine whether the triangles are congruent. We'll need to explain our reasoning. That makes sense. It's geometry. We got to be able to show that we know why we can do what we do. Do you see it? I think this is the way it's going to work. We're just going to take this triangle, we're going to flip it over, slide it over, set it down right on top of this guy, which means I know that side ED is congruent to side HG, and sure enough, the diagram shows that. I got 2.5 is congruent to 2.5. So ED is congruent to side HG. No problem. If I take this guy, flip it over and set it down there, I know that angle D and angle G are corresponding angles. They're the same angle, right? And they're congruent. The diagram tells me that. So I know that angle D is congruent to angle G. It's given to me in the problem. No problemo. Here we go. Keep going. One more time. We flip this guy over. Slide it over here. Set it down. Side DF is corresponding to GH. Side GH. Good grief. Side GJ. That's a tongue twister. GJ. And sure enough, the diagram tells me 1.7. So side DF is congruent to side GJ. And that, guys, that's good enough. Side, angle, side. That's all I have to do. If I can prove those three things, side, angle, side, two sides and the included angle, if I can prove that those guys are congruent, the side, angle, side theorem tells me the triangles are congruent. So side, angle, side theorem tells me that triangle DEF must be congruent to triangle GHJ. Right? Side angle side theorem. All right, guys, I got a couple more for you here. Let's just do a couple more example problems here before we go and move on to something else. Again, remember the idea here is this. We're essentially reducing the amount of work that we needed to do. CPCTC required you to prove 6 things. Side angle side theorem, you only got to prove 3 things. Half the work, hopefully half the time, working smarter, not harder. Here we go. I want you to prove using the congruence. I want you to prove congruence using the side angle side theorem. So here we go. Let's take a look at this guy. Here's what I've been given. I've been given that BD is the perpendicular bisector. Hey, that is a really important word. You guys should remember from a couple chapters ago what perpendicular bisector means. Perpendicular means that it intersects at a 90-degree angle, and bisector means that it cuts the segment in half. So BD is a perpendicular bisector. There it is, 90 degrees. And it cuts this segment, AC, in half. So I know that, boom, boom. Fantastic. I want you to write a proof to show that the 2 halves of a triangular window are congruent. Now, perpendicular bisector. Not only, right, perpendicular bisector, not only does it mean, right, that these 2, right, AD and DC are congruent, but bisector also means, right, that BD does what to angle B, or I'm sorry, angle ABC, right? This angle right here, ABC. If BD is a bisector, what does it do to ABC? It cuts it into 2 equal angles. So I know that this guy and this guy have to be, right? Those have to be equal measures because it's a bisector. Also, look down here, right? Perpendicular bisector means if angle CDB is 90 degrees, what do you know about angle ADB? Yeah, it's got to be 90 degrees. got to be 90 degrees. Okay, so here we go. Here's what we're going to show. I know that angle A, B, D, A, B, D, this guy right here, is congruent to angle C, B, D. Right? How do I know that? Well, perpendicular bisector, right? That's our definition of a perpendicular bisector. If it bisects an angle, it cuts the angle in half. Definition. Of perpendicular bisector. Okay, let's see. What else do I know? Oh, look at this. Check this out. Look. Segment BD has to be congruent to segment DB. Do you guys remember? We've seen this before. Do you remember what theorem tells us that? How do I know that segment BD is congruent to segment DB? Do you remember from previous sections? Right, that is the reflexive property of equality. The reflexive property of equality. Fantastic. Awesome. Well, okay, one last thing then, right? Because I've got side, angle. Okay, so here we go. I know, look, check this out, right? I know that angle BDC is congruent to BDA. Why? Well, it's a perpendicular bisector, right? By definition, it must intersect at a 90-degree angle. So, angle BD. Actually, here, let me do it in red since I've got it in red in my diagram. Angle BDC is congruent to angle, that was BDC, BDA, right? And that is the, no, sorry, I should have done this one. This one was in yellow. This one will be in red. That is the definition of perpendicular bisector. Sorry, I'm squeezing because I'm running out of room here. Okay, so here's what we've got. I have a side BD is congruent to side DB, side. I now have an angle, BDC is congruent to BDA, side, angle, side. All I have to do is show, right? Another side is congruent, but again, right? Perpendicular bisector. By definition of a bisector, AD must be congruent to CD. So, side AD must be congruent to side CD. Again, that is a definition. Perpendicular, oh, that looks like an I. I want that perpendicular sign. Bisector. And there we go. That's good enough, right? Look, side, angle, side. I've just proven that a side, an included angle, and another side of two different triangles are congruent, right? BD is congruent to DB. BDC is congruent to BDA, so side angle, and then side AD is congruent to side CD. Side, angle, side of two different triangles. So squeeze it in there at the bottom. Side, angle, side, congruence theorem. I know that triangle is congruent to triangle BCD by the side angle side theorem. Right? Because right here, side, angle, side. As soon as I can show that two sides in an included angle are congruent, which we just did, I know that those two triangles must be congruent. Let's do another one. Here's the diagram that you've been given. Got this nice little bow tie looking thing. Let's see what we've been given. You've been given that CD bisects. That's a really good word. We've seen this a number of times here now, so you should be pretty comfortable with what bisects means. We see that CD bisects AE. AE. And look at this. AE bisects CD. What? Yeah, this is awesome. Here's what this tells you. If line CD bisects AE, that means CD cuts AE into two equal segments. Right? Those guys have to be congruent because CD is a bisector. But AE is the bisector of CD. So that means AE cuts CD into two equal segments. What? I know, mind's blown. Mind's blown. Well, guys, you're almost there, right? I got sides. All you gotta do is show the included angles are congruent and you got it, side, angle, side. And hopefully you recognize it right away. We've seen this several times before. Vertical angles. Right? Those are vertical angles. Anytime you have intersecting lines will create two pairs of vertical angles. Vertical angles are angles that are congruent. They have the exact same measure. Hey, let's go ahead and write a proof for this guy. So here's what we know. I know this. I know that segment AB is congruent to segment EB, definition of a bisector. Yeah, cool. Here's what else I know. I know that C